All right, today we are going to look at drawing free body diagrams. So a free body diagram is a picture we draw that has all of the forces that are acting on an object. So if the object is actually pushing on something else, we don't include that force. We only include the forces that are pushing or pulling on that object. So I'm going to walk you through some of the different forces that we might have acting on an object and how to draw them. So you'll notice, first of all, I draw them as arrows, and you'll notice they all start at the object and point away from it. I like to do this just to be consistent, so even if something is pushing on my object, I will just go ahead and draw it on the other side as pulling the other direction. Okay, so the first one here is an applied force, so this is anyone applying a force, pushing or pulling on it, and I just label that with a capital F for applied force. Now there's a second type of applied force which we call tension. Now tension is from a string or a rope or a cable, something like that, and it always points along the string away from the object. Okay. We have the force of gravity, which is mass times the acceleration of gravity. So that is going to be our force of gravity, always acts toward the center of the Earth, and we use a G value of 9.8 here on the surface of the Earth. There's also the force of friction. Force of friction is going to act parallel to our surface here and oppose sliding. And then lastly, we have the normal force up here, where normal means it's perpendicular to the surface. That's what the word normal means here. It's a mathematical definition. So let's go ahead and see some of these forces in action. So I have a block being hung by two strings connected. Now because there's strings, that means I'm going to have some tension. And remember, tension acts along the string away from the object. So again, along the string away from the object. The length of the string doesn't matter, but when we draw our arrows, we like to draw longer arrows for bigger forces and shorter arrows for smaller forces. And then lastly, we also have gravity, which is acting down. Now, there's no one pushing on it, so we don't have an applied force. There's no surface involved, so I don't have tension or a normal force, and there's no sliding, so I don't have friction. Here's another example. I might put something on top of a inclined plane, and it just sits there. And so some forces I have acting on it there are gravity. Remember, gravity acts straight down toward the center of the Earth. Also have a surface now, so I need a normal force, and remember normal means perpendicular to the surface, so I apply a force perpendicular to the surface. We also have a force of friction holding there, and so force of friction, remember, is parallel to the surface and opposes any sliding. So this wants to slide this way, so friction's going to act that way. There's no tension because there's no strings, there's no applied force because there's no one pushing on it. So those are two examples of how we can draw a free body diagram, draw those forces acting on an object.